Which of the following statements is correct? Environmental degradation is an example of a free rider problem. No, the free rider problem is just that for public goods, they're non-excludable and non-rivalrous, so they're overused. Okay, but the free rider problem does not take into account the environment. The free rider problem is actually the problem for public goods, not common resources. The division between public goods and common resources is clear cut. So unfortunately, following that up, of course, the division between public goods and common resources is not clear cut because a public good can become a common resource if it is in fact overused and becomes rivalrous. And then we're going to look at D, the free rider problem prevents governments from supplying goods. No, the governments still supply the goods. It doesn't prevent them. It just creates an issue. Some goods may be either public or private goods. True, right? Remember, a roadway can transfer between public good, private good, or in fact, any type of good. So we know that goods can fall into any of the categories if they meet certain certain qualifiers. Question 2. Listed in the table are the long-run total costs for 3 different firms. Which firm is experiencing constant returns to scale? So constant returns to scale means that as inputs double, outputs double. And here we're going to assume that the cost that these firms are experiencing are the same for each worker. Or whatever else they need to produce. So, looking at this, we see that if their costs for firm A stay at 100, 100, 100, 100, 100, well, they're doing what? They're actually increasing their quantity, but their costs are staying the same, which means they're actually experiencing increasing returns to scale. They can produce more things without incurring more cost. So this is like an app. You can provide an app to more and more people without actually suffering more and more costs for it. So then firm A does not have constant returns to scale. Firm B, the cost always goes up by 100 for each additional unit of production that they're getting. So each additional unit always costs them a constant $100, which means that as they scale up, each unit is costing them the same, so they have constant returns to scale. Question 3. The diagram depicts the market situation for a monopoly pastry shop called Bear Claws. Based upon the information shown, what is the deadweight loss created by Bear Claws? So here we need to remember that the marginal cost function is equal to the supply curve in the market. And then the demand function is still the demand function. We always produce where marginal revenue equals marginal cost. That tells us what quantity to produce. In order to maximize our profits. All right, so then this is the point where marginal revenue equals marginal cost. We get a quantity of 70. If we trace that up to where it hits the demand curve, we can see that this green area here is going to be our deadweight loss, because that's the difference between where we would be at equilibrium at 90 at our equilibrium if we had a perfectly competitive market, but the monopoly produces all the way back here at 70, which is the monopoly quantity. So then that little triangle is going to be our deadweight loss. We're going to assume that marginal cost is a straight line here. So then the top of that hits at 14 and the bottom hits at 7. So we do the deadweight loss is equal to 1/2 14 minus 7 times the 90 minus 70. And that's going to give us this 90 minus 70 is 20, 14 minus 7 is 7, 1/2 of 20 is 10. So then that ends up giving us just 70. So the deadweight loss is $70. Question 4. For a monopolist, when the price effect is greater than the output effect, marginal revenue is. So remember, the price effect is how much does the price change affect our revenue, and the quantity effect is how much does the fact that we're now actually selling more of that good affect our revenue. Question 4. For a monopolist, when the price effect is greater than the output effect, marginal revenue is. Well, we know that marginal revenue is always maximized at the midpoint of demand, and that for a monopolist with a linear demand curve, the marginal revenue has twice the slope of the demand curve. So then whenever the price effect outweighs the output effect, then we know that our total revenue is actually falling, right? Because the price effect is how much do we get from lowering the price. So the revenue gained from lowering price, or I apologize, revenue lost from lowering price. And then the output effect is the revenue gained by selling more. So if we're losing more than we're gaining, we know that the marginal revenue must be negative, B. The following table provides information on the price, quantity, and average total costs for a monopoly. At what price will the monopolist maximize his profit? Well, going ahead and looking at this, we know that profit is maximized when what? Marginal revenue equals marginal cost. So then we actually have to do a bit of work here. We have to find the total revenues for each of these at the price, and then we have to find the marginal costs. So let me go ahead and delete this. So let's go ahead and make a total revenue here. Well, that's going to be equal to 0 if you don't sell anything. 18 times 5 is equal to 90. 13 times 10 is equal to 130. And 6 times 15 is equal to 90. So what can we see here? Our total revenue has fallen here. And a monopolist is always going to produce at a point where total revenue is not falling. So we can actually stop calculating total revenue here. And then next we can find our marginal revenues. So here our marginal revenue is equal to 90, and then it's equal to 40, then it's equal to negative 40. Lastly, we need to go ahead and find our marginal costs, but we need to first find our total costs. So the total cost is just average total cost times quantity. So 5 times 14 is equal to 70. 10 times 10 is equal to 100. Oops. And then 15 times 10.67 is something greater than 150. So then I know my marginal cost here are 30. My marginal cost here is greater than 50. So here we're not going to want to produce this because my marginal cost is higher than the marginal revenue. So we know we're going to stop at this production of 10, which means they're going to maximize their profit at 13.